Hello dear students, in the previous class we discussed maxima minima problems. This is a continuation problem, okay. In the previous class we discussed fifth problem, fifth question, sixth is considered as a homework, and now we are solving seventh problem, okay. Now what is given in this seventh problem? Here first we will write the given function, okay. Given function. First we will write the given function f of x is equals to 3x to the power of 4 minus 8x to the power of 3 minus plus 12x square minus 48 plus 25. Okay, this is a given function. Next step is differentiation. Here in the maximum minima, first write the given function, differentiate the function and make it equals to 0 to find critical points. Okay, to find critical points. And after double differentiation, substitute the critical point. If you will get negative, this is maxima. Okay, maxima. If double differentiation, substituting critical point, you will get negative minima, positive minima. Double differentiation, if you get 0, substituting critical point, double differentiation, if you get 0, then that is said to be a neither maxima nor minima. Now we will follow these steps in this problem. Okay, now first differentiate with respective x. Differentiate with respective x. So f dash x is equals to 3 into differentiation of x to the power of 4 minus 8 into differentiation of x cube plus 12 into differentiation of x square minus 48 differentiation of, let us say, 1 plus differentiation of x, this is okay, this is x, plus differentiation of constant. Here f dash of x is equals to 3 into differentiation of x to the power of 4 is 4 into x to the power of 4 minus 1 minus 8 into differentiation of x cube is 3x to the power of 3 minus 1 plus 12 into differentiation of x square is 2 into x to the power of 2 minus 1 minus differentiation of x is 48. So therefore this differentiation constant is 0, therefore I am not writing that. Here we are getting f dash of x is equals to 3 4s are 12, okay, 12 x to the power of 3, right, x to the power of 3 minus 3 8s are 24 x to the power of 2 plus 12 2s 24 x minus 48. Okay, now here I am taking common 12. F dash of x is equals to, take common 12. So if I take common 12, x cube minus 12 2s 24, so 2x square plus 12 2s 2x minus 12 4s 48, right. So here f dash of x is equals to this is the factor we have let f dash of x is equals to 0 to find critical points, critical points. Therefore make it 12 times of x cube minus 2x square plus 2x minus 4 is equals to 0. Now here we'll send it to the right hand side, it will become a 0. So x cube minus 2x square plus 2x minus 4 is equals to 0. Here cubic is there, cubic equation. In order to find the roots, we will follow the Hornell method. Okay, Hornell method. So here x cube coefficient first we will consider. Here in Hornell method, cube is reduced into the square. Okay, cubic equation reduced into the quadratic equation, so we can able to find very easily roots, right. So here x cube coefficient is 1. X cube coefficient means x cube beside term is 1. If we don't have anything, consider as a 1. X square coefficient is minus 2 and x coefficient is 2 and here minus 4 is a constant. Here left side we have to consider one root. Okay, let us consider randomly. If I put here 1 in this equation, will it become 0? No. If I substitute minus 1, will it become 0 in the place of x? If I substitute minus 1, will it become, the entire equation will become 0? No. If I put x is equals to 2, let us consider x is equals to 2, I put it in this equation. So 2 cube minus 2 into 2 square plus 2 into 2 minus 4. So this is 2 cube is 8 minus 8. 2 2s are 4, 2s are 8. So 2 2s are 4 minus 4 plus 4 minus 4 plus 8 minus 8 get cancelled. Therefore, if I substitute x is equals to 2 in this equation, then you are getting 0. Therefore, x is equals to 2 is the root of the equation. X is equals to 2 is the root of this equation. So therefore, I am considering x is equals to 2. Now fixed. 0 is fixed here. Okay. 1 plus 0 is 1. 1 into 2. Just multiply here. Result. Result is multiplied by root. 1 into 2. 2. Now minus 2 plus 2 is 0. 0 into 2. 0. 2 plus 0 is 2. 2 2s are 4. This is 4. Hence here cube term is reduced into the square term. Now here we will write here x square, x and constant. Okay. The cube term is reduced into square term. Now here x square, x, this form can be written as x square, 1x square, here plus 0x plus 2. This is quadratic, and x is equals to 2, send it to the left hand side, it will become x minus 2. Therefore this is one factor is equals to 0. Hence x cube minus 2x square plus 2x minus 4 is equals to can be written as x minus 2 into x square plus 2 equals to 0. Therefore we got here factor a into b is equals to 0 means a into b equals to 0 means either a is equals to 0 or b is equals to 0. In similar way, x minus 2 is equals to 0 or x square plus 2 is equals to 0. Therefore x is equals to plus 2. If I send it to the right hand side, it will become plus 2. Here x square is equals to minus 2. X is equals to root over minus 2. No real roots. Okay. Here root over negative we will consider as a complex number. Okay. This is not a real root. Therefore we will consider real root. X is equals to 2 is a critical point to this equation. Okay. Answer. The function f dash of x is equals to we have a critical point. Now what we are supposed to do? Double differentiate the function. Okay. Double differentiate the function. Now consider the function. What is this function? So I am just considering this function and double differentiating the function. Okay. This is a differentiate the function. Differentiate again with respective x. So we got double differentiation, x is equals to 12 into differentiation of x cube is 3x square minus differentiation of x square is 2x plus differentiation of x is 1. Therefore your constant differentiation is 0. Okay. Double differentiation of x is equals to 12 into here 3 2 here 2 2s are 4, 3x square minus 2 2s are 4 into x plus 2. Therefore we have to substitute extreme value, x is equals to 2. So double dash of x at x is equals to 2. So substitute here. Is this 2, right? Yeah. 12 into 3 2 square minus 4 into 2 plus 2. Now is this the result? Is this the result positive or negative? 12 into 2 2s are 4, 4 3s are 12, 2 4s are 8 minus 8 plus 2. Therefore you are getting what? 12 minus 8 4, 4 plus 2 6, 4 plus 2 6. So 6 2 6 are 12, 6 1 is 6 72. Therefore double differentiation is positive, which is greater than 0, and this is minima. Hence minima. Okay. Double differentiation is positive means minima. And where it is minima? x is equals to critical point, x is equals to 2 is the point of minima, x is equals to 2 is point of minima. Okay, now what is asking in the question? Point of minima. What is asking in the question is asking find both the values, maximum value and minimum value, and also a given interval 0 3, so we have to include 0 and 3 also. Okay, now consider the function, 0 3 and 2. Now substitute in the place of 0 and 2 and 3. Here we are substituting point of minima. We have to substitute this 0 2 3 in the function. Okay, what is function here? Here the function is given function. What is given here? This is a given function. Okay, this is a given function. We have to substitute in this of x 0. 0 into something will become 0, everything will become 0, remaining is 25. This is positive. And if I substitute 2 here, 2 means 3 into 2 to the power of 4, 16. Okay, minus 8 into 2 to the power of 3 is 8, plus 12 into x square means 2 square. 2 square is 4. 2 square is 4 minus 48 into 2 plus 25. If we calculate this 3 16ths minus 8 8 is 64, 48 minus 48 into 2 plus 25 is equals to 39. Minus 39 is the answer for the f of 2, and f of 3 if I substitute 3 into 3 to the power of 4 means 3 3s are 9, 9 3s are 27, 27 3s are 81. Okay, 81 minus 8 into 3 cube means 27. Okay, plus 12 into 3 square. 3 square means 3 square 9 minus 48 plus 48 into 3 plus 25 equals to, here the result is if I calculate everything you will get 16. Okay, so which is maximum value here? 25 is the maximum value, and corresponding here where is it is maximum at x is equals to 0, it is maximum. Okay, here now we can say here maximum value is maximum value is equals to 25. Where it is maximum at x is equals to 0, it is maximum. So x is equals to 0 is a point of maxima. And where it is minimum, minus 39 is a minimum value. So minimum value is equals to minus 39. Where it is minimum at x is equals to 2, it is minimum. So at x is equals to 2 is the point of minima. That's all. This is the result. What is asking? Minima and maxima, right? So this is a solution. So here first given function, differentiate the function. Okay, differentiate the function and take common 12. You will get the x cube minus 2x square plus 2x minus 4. Make it equals to 0 in order to find a critical point. So consider x cube coefficient, x square coefficient, x coefficient constant. So I consider by using Hornall method. We found one root and reduce the cubic equation into quadratic equation, and from there x square plus 2 is the complex roots you will get. That's the reason we are not considering this. And we consider x is equals to 2, therefore f dash of x is equals to, this is a function, differentiation of function. Now we have to differentiate, double differentiate. Again differentiation gives you double differentiation, therefore you will get one result. In that result substitute critical point. If the critical point is positive means definitely it is greater than 0 means minima. Okay, where it is minima at x is equals to 2, it is a point of minima. This is a point of minima. Yeah, critical point is a point of minima, but we don't know minimum value. So substitute given values. What are the given values here? Given values 0 comma 3, in between 0 comma 3 we got critical point 2, therefore 0 3 2, we are considering all those three values. Okay, 0 2 3 we substituted in the function, we got the data. This is the result, that's all. This is the solution. Here we have 13th question, remaining whole or homework. Okay, find two numbers whose sum is 24 and whose product is as large as possible. Whose product is as large as possible. Now here the given statement, first of all we have to frame the function. Okay, we have to frame the function, differentiate the function and make it equals to 0. Let f dash of x is equals to 0 to find critical points. Okay, to find critical points. So double differentiate the function, substitute the critical point. If it is positive, that is minima. If it is negative, if I substitute critical point in the double differentiation, if it comes out to be negative, then that is said to be a maxima. Okay, double differentiation, if the result comes out to be 0, then that is said to be neither minima nor maxima. Now we have to frame the function. Okay, frame the function. Now what we have to consider the function here, the given statement, find two numbers whose sum is 24 and whose product is as large as possible. Okay, now let x and y be the two numbers. X and y be two numbers. Therefore sum is given, sum is equals to 24. Sum of two numbers is given. So what is sum addition of two numbers? So x plus y is equals to 24 is the call it equation 1. Now whose product is as large as possible. Whenever you hear a large, maximum, we have to consider that as a function. Okay, here the function is product given. So function is equals to product. So product means what? Product of two numbers. Okay, here function, product of two numbers. So I am considering x and y are the two numbers. This is the function, right? So here we have x into y. Two variables we have. Use equation 1 in order to make it single variable equation. So substitute in the place of y from here. Send this x to the right hand side. It will become 24 minus x, right? So I am substituting 24 minus x in the place of y. So x into 24 minus x. This is the function. This is in the form of x in terms of x. So I am considering this function is f of x is equals to x into 24 minus x. So this x is multiply inside. Okay, f of x is equals to 24x minus x into x square. Okay, now differentiate with respect to x. So f dash of x is equals to 24 into differentiation of x is 1, differentiation of x square is 2x. Okay, differentiation of x square is 2x. Now let f dash of x is equals to 0 to find critical points. Okay, critical points. So here f dash of x is what? 24 minus 2x is equals to 0. Okay, now in the next step send this to 2x to the right hand side. 2x is equals to 24 remains. Okay, next step send this 2 to the right hand side. It will become 24 by 2. 2 1s are 2 2s are 4. Okay, x is equals to 2 be the critical point. X is equals to 12. X is equals to 12 is a critical point. Next we have to double differentiate the function. Okay, what is the given function here? Here this is the function, right? F dash of x is, right? Equation 1 implies what is the function here? Function is the differentiation of function is what? 24 minus 2x. Now again double differentiate the function. Okay, differentiate with respective x. So double differentiation. f dash of x is f double dash of x is equals to differentiation of constant is 0 minus 2 into differentiation of x is 1. Therefore, double differentiation of x is equals to minus 2. Here we don't have a variable, so no need of substituting the critical point in the function. Okay, therefore double differentiation is less than 0. It is maxima. It is maxima. Where it is maxima at x is equals to 12, it is maxima. X is equals to 12, it is maxima. He is asking x is equals to 2 and what is the value of y simultaneously. Okay, from the equation y is equals to 24 minus x, right? So substitute in equation 1. Substitute in equation, oh my god, this considers equation 2, okay, and this is equation 2. Equation 2 implies f dash of x is equals to 24 minus 2x. Now here we have to consider x plus y is equals to 24. Okay, substitute in 1. So x plus y, or else substitute in x plus y is equals to initial equation. What we have here in initial equation 24. So substitute x is equals to 12. 12 plus y is equals to 24. Send this 12 to the right hand side. Y is equals to 24 minus 12. Therefore, y is equals to 12. Therefore, we can write it as x is equals to 12, y is equals to 12. At x is equals to 12, y is equals to 12, function reaches to the maximum. Function reaches to maximum. That's all. This is the solution. Clear? This is the solution. First step is framing the function. We frame the function. Okay. Now, next, differentiate the function, make it equals to 0, finding critical point. Next step is double differentiate the function. Double differentiate the function. Double differentiate the function and substitute the critical value in that. You will get negative means less than 0 means maxima, and x is equals to 2 is the point of maxima. X is equals to 2 will substitute in basic equation. What we have, x plus y is equals to 24, you will get y value. Therefore, at x is equals to y is equals to 12, function reaches maxima. That's all. This is the result. Clear? Here remaining same problem are same model problems are homework. Okay, consider as a homework. 17th problem. Here we have a square piece of 10 of side 18 centimeter is to be made into box without top by cutting a square from each corner, folding up the flaps to form the box. Okay, now first of all we will consider a square tin. Okay, a square tin. A square tin, side is 18 centimeters. Okay, side is 18 centimeters. Okay, 18 centimeters side is so square means all sides are equal, right? Now what is asking, by cutting a square from each corner. Okay, we will cut the square, small square from each corner. Okay, now I am cutting this part. I am cutting this part and I am cutting this part, small squares from the edges. Okay, so I cutted this part. I cutted this part square. What should be the side of the square to be cut off so that the volume of the box is maximum possible? Maximum possible. So he is asking at what value of a square, at what value of a side of a square should be cutted so that the box can be, it can generate a maximum volume. Okay, now let us consider this side. This side is x. Okay, and this side is x. Okay, this side is x, this side is x. Clear? Next, this is the side x. Here we are cutting side. Let x be the side of a square cutting from edge. Okay, from edge. So here if we cut this, remaining space is how much here? X, 2x. We are subtracting from the total distance. So what is this distance? 18 minus 2x, right? So let us consider here. This is a base. Okay, this is a base. Here, base is this. I am flipping this side. Okay, I am flipping this side. So I am flipping this side. Next, I am flipping this side also. Okay, I am flipping this side. In similar way, I am flipping this side also. See, as we can observe, and remaining side is also I am flipping. I can get a box, right? Topless box. So this is a box. So but height is what? Here height is what we cut it, that one only, right? X is the height. And here the side is 18 minus 2x. So this length and width both are 18 minus 2x because this is a square box, right? So 18 minus 2x is the side and this is also 18 minus 2x. Therefore here the function is volume, right? Here what is asking? Volume to be the maximum. So here function is volume. Function is volume. Okay, function is volume. Let us consider a function is f of x and a volume. Volume of the box is length into breadth into height, right? Length is what? 18 minus 2x. Breadth is what? 18 minus 2x. Height is what? X. Clear? Now, f of x is equals to x into 18 minus 2x whole square. Hence we got function. Hence we frame the function. Okay? Hence we frame the function. Now from here, differentiate the function. Differentiate with respective x. So f dash of x is equals to UV rule. Okay, differentiation of x into 18 minus 2x whole square. So UV rule, formula is what? UV rule, UV dash is equals to UV dash plus VU dash. So here also following the same formula. Okay, U differentiation of V, 18 minus 2x whole square plus 18 minus 2x whole square into differentiation of x. Differentiation of x. So from here, f dash of x is equals to x into differentiation of x to the power of n, n into x to the power of n minus 1. But this is not x, again differentiation. Okay, differentiation of 18 minus 2x plus, this is same as this, 18 minus 2x whole square, write it. And differentiation of x is 1. Okay, therefore f dash of x is equals to 2 into x, 2x, 18 minus 2x. Differentiation of 18 is 0. Differentiation of constant is 2 into x, x variable. So we are differentiating x is 1. Therefore 18 minus 2x whole square, this is next. F dash of x is equals to minus 2 into 2 minus 4x, 18 minus 2x plus 18 minus 2x whole square. So take common here. Take common 18 minus 2x. Okay. F dash of x is equals to 18 minus 2x take common. 18 minus 2x take common. And remaining write it minus 4x plus 18 minus 2x. Okay. Here 18 minus 2x. So f dash of x is what? F dash of x is equals to 18 minus 2x into minus 4 minus 2 minus 6x plus 18. Okay, minus 6x plus 18. Therefore let f dash of x is equals to, make it equals to 0 to find critical points. To find critical point. Okay, critical point. Therefore f dash of x is equals to 0. Here the f dash of x is what? 18 minus 2x into minus 6x plus 18 equals to 0. Here we have getting 18 minus 2x is equals to 0 or minus 6x plus 18 equals to 0. Send this 6x to the right hand side, it will become 6x is equals to 18, minus x becomes plus 6x, minus 6x becomes plus 6x is equals to 18. 6 3s are 18. So x is equals to 3. Next, send this term to the right hand side. 18 is equals to 2x. So x is equals to 2 9s are 18. So x is equals to 9. We got the two critical points. Let me check. If x is equals to 9 means here x is equals to 9 means 18 minus 2x. 18 minus 2x means, let us say 9. Substitute here. 2 9s are 18. 18 minus 18, 0. That means this distance is 0 you are getting. That means this is doesn't exist. Therefore, what we are considering, this is not exist. Therefore, x is equals to 3 we will consider. Okay. Next, double differentiate the function. What is given function here? Given function. Now double differentiate the function. Okay. Double differentiate the function and substitute the double differentiation critical point in the double differentiation. What is differentiation of function here? Differentiation of function is 18 minus 2x into minus 6x plus 18. Okay. Now double differentiation is UV rule again. U V dash. Differentiation of this is differentiation of x is 1 minus 6. Differentiation of constant is 0. Therefore, I am not writing. Plus V U dash. U dash is what? Differentiation of constant 0. Differentiation of x is 1. Therefore, this is minus 2. So here clearly we are getting minus 6 into 18 minus 2x minus 2 into minus 6x plus 18. If I substitute critical point, what is critical point? X is equals to 3 is the critical point, right? This is the critical point. If I substitute here 3, so minus 6 into 18 minus 3 2 is 6 minus 2 into minus 3 6 are 18 plus 18, 3 6 are 18 plus 18, 0. This is 0. And this is 18 minus 6. 18 minus 6 is positive, therefore minus is there. Positive into minus negative, therefore f double dash of x is you are getting less than 0, and therefore it is maxima. It is maxima. And where it is maxima? At x is equals to 3 is a maxima. X is equals to 3 is point of maxima. Okay. Now what is asking? Is asking at what value of here, what should be the side of the square to be cut off so that the volume of the box is a maxima. So at x is equals to 3 is the side we have to cut. X is equals to 3 is the side of a square to cut to get maximum volume. That's all. This is the solution. Okay. Let me explain once again. First function, differentiate the function. Framing the function is important. Okay, framing the function is important. We cutted the box and we made the square. We got the dimensions, and now length into breadth into height. Here length breadth the same, so square. X into 18 minus 2x, 18 minus 2x whole square. This is now differentiate with respect to x. We got the differentiation result and make it equals to 0. Okay. Here after simplification we made equals to 0. We got x values 2. Okay. X is equals to 9. X is equals to 3. But we are not considering x is equals to 9 because at x is equals to 9 distance is 0. So can't be 0. So we have a distance. So therefore this is not doesn't exist. At x is equals to 3, it is exists. So I am considering x is equals to 3 is a critical point. Now double differentiate the function. Double differentiation of the function and substitute the critical point. If it is negative, hence it is the maxima, and point is x is equals to the point of maxima. Therefore x is equals to 3 is the side of this square to get the maximum volume. That's all. This is the solution. Here we have a question. A wire of a length 28 meters is to be cut into 2 pieces. Okay. Here let us consider length is L. Okay. In generalized format. I am considering L is the length. Okay. So here 28. Instead of 28 I am writing L. L is the length. Okay. Now a wire of length L meters is to be cutted into two pieces. Now this is a length of wire. Okay, this wire is a length L. Length L. Okay. One of the pieces to be made into the square. So from this length of the wire, we cutted the one part of the wire, like part of the wire. From here to here, let us say this part is X. Okay, then what it will become here? Pi minus X, right? Sorry, L minus X. L minus X, you will get the other length. Let us call it A, B, C. Okay. AB. With the AB we are making a square. Okay. AB we are making square. Square. What is the side of the square? All sides are equal, right? Here x divided by 4. This is the side of the square. 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 And this is made at circumference of a circle. Making a circle. Okay. Making a circle. This is making a circle. Now we don't know the radius, but circumference of the circle is 2 pi r is equals to, we know, L minus x. We know L minus x. Now from here, can I find L minus x by 2 pi be the radius, right? So from here, the function what is asking, what should be the length of the two pieces so that the combined area of the square and the circumference is circle is minima. So here the function, let side of square be x by 4, okay, and radius of a circle be L minus x by 2 pi, okay, 2 pi. Now what is asking? Area. So area is asking. Frame the function area, a of x. Let us say a of x is the function. Area of the square is what? Side square plus area of the circle is what? Pi r square. But here r is what? R is L minus x pi r square. So write here area A is equals to x square by 4 4 is 16 plus pi into r is what? L minus x by 2 pi whole square. So A is equals to x square by 16 plus pi into L minus x whole square by, here square apply, 2 2s are 4 pi square. Therefore 1 pi get cancelled. From here this is the area actually, right? Area. Now let differentiate the function. Differentiate with respective x. So dA by dx is equal, so differentiation of x square is 2x by 16 plus differentiation of this part is 2 into L minus x whole to the power of 2 minus 1. Here differentiation of f of x whole to the power of n can be written as n into f of x whole to the power of n minus 1. Differentiation of f of x is f dash of x. Okay, this is the formula we are using here in this. This is the formula we are using in this. So 2 into L minus x whole to the power of 2 minus 1, again differentiation of inside function. L differentiation is 0, x differentiation is 1, therefore by 4 pi. So here 2 2s are 4, 2 8s are 16. So dA by dx is equals to x by 8 plus into minus and L minus x by 2 pi. L minus x by 2 pi. Now let dA by dx equals to 0 to find critical points. So here x by 8 minus L minus x by 2 pi equals to 0. From here send this term to the right hand side. X by 8 is equals to L minus x by 2 pi. So 2 4s are 8. 2 4s are 8. So cross multiplication, pi into x, pi x is equals to 4 into L, 4L minus 4 into x, 4x. This 4 is multiple to the each and every term. Okay. Next. So bring this 4x to the left hand side. Pi x plus 4x is equals to 4L. Okay. X take common. So pi plus 4 is equals to 4L. Equals to 4L. Where send this term to the left hand side. 4L by pi plus 4. This is the x value. This is the x value. This is a critical point. Okay. This is the critical point. Now here call it a differentiation. Single differentiation is 1. Okay. Now we got the critical point. We have to differentiate now. Double differentiation. Okay. Now consider double differentiation. So equation 1 implies what is given, dA by dx is equals to what? X by 8 minus L minus x by 2 pi. Now differentiate with respective x. So this is d square a by dx square is equals to x square, x differentiation is 1 by 8 minus L differentiation is 0 minus x differentiation is 1 by 2 pi. Therefore here minus into minus plus 1 by 8 plus 1 by 2 pi. Therefore which is greater than 0? It is minima. It is minima. Okay, it is minima. Therefore we can say here x is equals to 4L by pi plus 4 be the point of minima. Okay, that's all. What is asking is asking to find x. What is x, right? What is x? What should be the length of the two pieces? So here x is the length of the two pieces, right? First piece AB, first piece which is made by the square, that length is what? 4L by pi plus 4. And here second is what? So other length is L minus x be the other length. This is other length. Other piece of length. Other piece of length is L minus x. So L minus x can be written as L minus x is what? 4L by pi plus 4. Therefore take LCM. So here pi into L plus 4 into L. We are multiplying this term to the L. Okay. So minus 4L by pi plus 4. Therefore L minus x is equals to plus 4L minus 4L cancel, pi L by pi plus 4. That's all. This is the other side of the piece of length. Okay. Piece of wire, other length. Therefore these are the two solutions. That's all. Clear? Consider a piece of wire L. Here given the dimension, but if it is changes from question to question, so better to consider L. Okay. So we divided this piece of wire into two pieces. Let us consider length of the wire. First wire is x and BC wire is L minus x. So here with the AB line, AB piece of wire, we made a square, that is x by 4, x by 4, x by 4, and BC wire piece of wire, we made a circle, circumference. So radius is L minus x by 2 pi. L minus x by 2 pi. From there we substituted in the formula. Area we will consider as a function because area is given minima. So here area of the square is this, x by 4 whole square plus pi r square circle. So r replaced with the formula L minus x by 2 pi. So substituted here and squaring, simplifying, you will get equation 1 which is dA by differentiating. You will get equation 1, make it equals to 0. You can find the critical point of 4L by pi plus 4. Double differentiate the function, you will get positive. This is minima, and therefore x value is point of minima. We have 1x and we need to find L minus x, the other piece of the wire, L minus x. So therefore we got those two results. That's all. This is a solution.